Hi, welcome to Foundation Analytics Skills Training. This is session 1 of 3. Before we get started, I just want to briefly introduce myself. My name is Michael Fitzgerald. My background, I have a doctorate in energy and mineral engineering from the Penn State University, where I also hold a master's in energy and geoenvironmental engineering, a bachelor's in environmental systems engineering, and I've also been an instructor of hydrology and contaminant hydrogeology. My professional career, I'm a senior analytics engineer at the Seeq Corporation, where I work on the training team, helping folks like you learn how to use the platform that we'll use to solve our data analytics problems here. Previous to working at Seeq, I was a Deputy Assistant Director of Aquatics at the National Ecological Observatory Network. This project here is a National Science Foundation funded project where we developed a continental scale observation platform to monitor for the effects of climate change. As part of my role there, I was a lead engineer to design and develop the aquatic instrumentation system, which was large sensor packages that we would deploy across the country to monitor water quality and atmospheric conditions of small stream sites and stream systems around the country that we could then use to look at changes in ecology over the time period. Previous to this work, I was an environmental engineering consultant on soil and groundwater remediation projects, largely at Department of Defense sites. So you may be asking yourself, what are the foundation analytics skills? Well, think about the last time you used math and analytics to understand what was happening in your processes, why it was happening, or what might happen in the future. If you're like us, setting up the analysis so that you're asking the right questions and analyzing the data in a way that will rigorously address those questions can be challenging. The foundation analytics skills are a method and set of steps for setting up and solving a wide range of analytics problems common in the process industries, and in fact, even outside industry. Most analytics of any kind use the skills we'll lay out here, and we hope you find it useful. At the beginning of each of these sessions, we'll talk briefly about the skills we're covering. Then we'll get right into the hands-on exercises in which we'll practice the skills in a context of real-world use cases with real data. So we'll practice the skills not in a manicured and perfect environment, but as they are really applied on dirty data with imperfect running conditions. So we'll learn the skills as we really use them. In this session, we'll focus on the first 2 skills here of identifying periods of interest and quantifying. But let's get an overview of all the skills before we get started. So right here in this kind of image are the foundation skills. The first skill is to identify periods of interest in your data. How often have you used all of the data in your possession in an analysis? Most analyses start by identifying time periods in the data, startups, shutdowns, events, production periods, etc. Many calculations involve only certain periods in the data. For instance, you might want to calculate KPIs and metrics only when the equipment is running, or maybe during a startup period or at certain reaction stage or product or production type. Or maybe you want to calculate something over a daily or monthly periods and shifts. So the first skill is to learn all the ways we can identify these periods of interest in the data, which we call conditions in Seeq. We'll get an overview of different types of periods of interest and guide you through this concept in the exercise. Data cleansing is often the second step in an analysis after identifying the data you want to work with. The cleanse section shows how to remove bad data, outliers, and downtime or other periods from the data, as well as how to filter or smooth, remove drift, adjust, and shift signals, and more. After the data are cleansed, if needed, we'll move on to the quantifying skill. After the data are cleansed, we move on to the, if we need to, After the data are cleansed, we move on to the quantify skill, which refers to calculating KPIs, metrics, and more. For instance, we might want to calculate total production each day, or the duration of startup periods, or the percent uptime each month. We can also do calculations using, say, thermodynamic or other equations. Again, we'll see an overview of types of calculations when we get to that point in the exercises. Once we know what is happening and what tags and variables contribute to our KPIs, we often wonder what will happen in the future. Model and predict covers building multivariate regression models, which might include soft sensor models, predictions of product quality based on process variables, etc. We can also build predictions based on time or forecasted signals. This approach is often used to predict equipment maintenance. Visualize refers refers to the approaches and tools you use to summarize, visualize, and present data so that's most useful to others in your organization. Visualizing includes evaluating data against operational limits or thresholds, graphing ideal behavior or golden profiles, and being able to see deviations from that behavior. It also includes visualizing the same analysis across assets, building dashboards that show multiple KPIs and figures, building tables with metrics. Finally, throughout the exercises, we'll document our work in detail and share it with others. The journal allows us to create bookmarks to certain steps, time periods, and data using Seeq links. For instance, you can create a link that snapshots any step in your analysis and come back to it at any time. Finally, we'll make reports and dashboards that update automatically or on demand, and learn some convenient report building tips and tricks to effectively share and communicate with our colleagues. This knowledge capture is really a key concept in digital transformation because after all, you can do the coolest analysis in the world, but it's not worth much in a business sense if you can't clearly communicate throughout your organization the needs and benefits revealed by the analysis. So think about what analytics projects you've done. Chances are, whether you're monitoring or seeking to describe what is happening or has happened, investigating or diagnosing why something happened, or seeking to predict what will happen, you're using a combination of the skills above. So to get started here, we first want you to we need to log into the software that we're going to use here. And the software we're going to use is the Seeq application software. So please log into the Seeq's learning server by following the instructions in the CFE course documentation. You're going to get to a login screen. In the login screen, you'll see that you'll use your username will be your email address, and your password will be your email address, all in lowercase. You should see a folder with your name on it, and I'll cover that here in just 1 second when I switch screens. And just click on this folder to open it, and I'll take you from there in a second. If you have any issues logging in, please email training@seeq.com, and we'll help you get logged in. So following the description in the CFE course materials, you should have a link to log in to the Seeq learning environment. This is on learn.seeq.com. This is where we'll do all of our analytics over the next, through the rest of the session, the next 2 sessions. To log in here, you're going to use your email address as your username and your email address, all lowercase, as your password. So I'll do that and I'll click login. And when this loads up, we should see a folder with our name on it. So we get into Seeq's learning environment. We'll see that we're in the CFE Foundations class, and I see a folder here with my name on it. I'm going to open that up. There's 2 files inside. One is Foundation Analytics Skills Training, and the other is Organizer Training Template. I'm going to open up the green file here, Foundation Analytics Skills Training. And over just a quick kind of overview of what this is Seeq's workbench analysis. On the left-hand side are a series of different worksheets. This is where we have all the exercises pre-built into it that we'll go over for the next couple of days. If I wanted to add another worksheet, I could choose new worksheet, which is this plus sign here at the top in the upper left. And then I have 3 different tabs and kind of in this middle section. First tab here is data. On the data tab, this is where all of my data will be connected to, where I can search for it. I have a tools tab, and these are kind of the pre-built analytics tools as well as formula, which is a way that we can just write our own custom equations. And then we have the journal tab as well. And journal is where we're going to see all the exercises that we're going to work through. But more importantly, this is also where we can keep information about the analysis that we're doing. So remember, you can do the coolest analysis in the world, but if you can't really document your steps and what you've done, it's really hard for someone else to follow along, which makes it even harder for them to actually gain insight from the work that you're doing, or even know if you did your steps correctly. This is where we'll be able to add context and really talk about what we're trying to do here and how we solve our problems. The big open white box here, this is where all of our data is going to come into once we bring in the different signals. And then we have a details tab down at the very bottom or a details pane rather, where we can have information about the different signals we're bringing in. That's all I'm going to do for the overview right now, because everything will make a lot more sense as we start working through it. So to get into the first exercise on the left-hand side, I'm going to navigate down to ID1, Intro to Conditions, and you should join me here. So I'm going to click on ID1, Intro to Conditions. And if you remember when we were talking about the different wheel of analytic skills, identify is really the first skill. And the reason it's the first skill is because in any analysis, the first thing you want to do is identify the data that you want to do your calculations on. So maybe I'm trying to find an average temperature or an average condition that's occurring when I exceed some certain threshold, maybe in a temperature signal in a process. So maybe I want to know when my temperature is above 95 degrees. When it's above 95 degrees, tell me the duration that it is above that temperature, so I can figure out if my process is running well or poorly or what's going on there. So the first step in almost all analytics is to identify the time periods we want to look at. And this is either events, states, or sections of good data, or even bad data. And in Seeq's term, we can do this using conditions. And so to get into that a little bit, we're going to do all of these exercises kind of have a little bit of a story to them. And the first story that we're telling, and the first kind of use case problem that we're solving here is we are looking at material flowing through a system. And eventually we're going to be looking at material flowing past a valve. And what we're trying to do is find out when that valve is leaking, so that one, we can understand how we need to plan maintenance around this piece of our equipment, let's say. And so we'll be kind of describing the analytic skills as we solve this problem in this scenario. So the first thing we want to do is we want to find periods when material is flowing. To do that, the very first thing we need to do is actually bring in some data. The first data signal that we want to bring in is feed rate Seeq. So the easy way to do it is I'm going to highlight the words feed rate Seeq, copy it, go to my data tab, and paste it into the search bar here at the top and choose search. When I choose search, I have one example. I'm just going to click on it, and I see I have a feed rate that shows up here in the right-hand side. We have the name for feed rate. It's in kilograms per hours. We have 1 day's worth of data that we're showing here. And then we want to bring in the next signal, which is feed rate limit Seeq. So I'm just going to go ahead and copy feed rate limit, bring it into data tab, choose reset, paste it in, search for it, and then again, just click on it once so I can load it in. And the names and the labels have already been brought in, but if they weren't brought in, I could go up to the word labels and I can add my name to the lane. So let's say when you first see it, it probably looks a lot more like this. So I'll come through and I'll add my name to the lane. I'll add my unit of measure to the axis. And then I'll add my condition name to the lane. And don't worry, we'll talk about what conditions are in a second if it doesn't make sense to you already. I can click once outside of the box. And now I want to co-align both axes on the same lane. So both signals are going to show up in the same kind of swim lane here for us. I'm going to choose one lane and one y-axis. And then choose reset and go back to my journal. And so now when I look at this, what I have is a feed rate. So whatever my material is, maybe it's rock flowing through a conveyor belt, maybe it's oil flowing through a pipeline, whatever that feed rate is, or whatever that material is that's flowing, we're just going to look at the rate at which it's flowing in terms of kilograms per hour. We have some limit. And what we can do is we can say that anytime the feed rate is greater than the limit, we can define and say that the material is actually flowing in our system. And so that's a really important first criteria for us. So to do that, we're going to actually mark out those periods of time using the software here. I'm going to go up to the Tools tab. So I'm going to choose Tools. And I want to identify something. So I'm going to create conditions to find events or capture periods of interest. So I'll select identify, and then I have a series of different options under there. The first option I'll choose is a value search. And I want to find when a signal is greater than, less than, or equal to another signal or fixed value. So I can select that. And now I just need to give this a name. So I'm going to call it material is flowing. So just giving it a quick definition, a name here, select a signal I want to search. That's going to be my feed rate Seeq. And then we're going to stay in a simple operator for now. The operator that we want to use is greater than. And I can either enter in a numeric limit here, or I can use a signal. I'm going to use a signal that I already have brought in, which is my limit signal. So I'm just going to choose this option to the right. And now I can select the limit, which is a feed rate limit Seeq. Don't worry about ignoring signal gaps or short capsules. We'll touch on what those mean in a little bit here. And then I'm going to choose execute. So when I do that, what I see is that every time that my feed rate exceeds this green line, so every time my feed rate is greater than a limit, I get a little bar that marks out that period of time. And this is really important because Seeq is going through now and identifying just the data that where the criteria is true. And the criteria for us is when is the feed rate greater than the limit. So it's kind of the first stage, and we can see our name shows up here, which is material is flowing. Down in the bottom, we see these little squiggly lines. These mean that this is a signal that's coming through. We have our units, we have the name of our signals, and this image here means that this is a condition. When I hover over it, I see the word condition, and then my name for the condition. Okay, so now that we've kind of created our first condition, let's actually talk about what that is. So I can choose this arrow under my journal where it says edit, the 3 dots, and then the little arrow to the right. Select that. And I'm actually just going to zoom this up so it's a little easier for us all to read here. But what is a condition? A condition indicates when an event is occurring. So our event and how we defined it is we're saying that we want to mark out a period of time where our feed rate is greater than our limit. And so anytime our feed rate is greater than the limit, mark it out and let me have access to that data. So that's really what we did. A single period or event is called a capsule. So in this example, this one bar here is called a capsule, but then this larger collection of them is called a condition. And so why do we want to use conditions? Well, most analyses concern specific time periods, condition states, etc. We use conditions to quickly and easily identify events and periods of interest. This allows us to visualize and calculate metrics during these periods. We can find combinations of conditions. We can calculate process metrics during conditions that align with financial or other data. And we can identify and diagnose production issues. And that's kind of what we're going to do in this exercise here. So for example, we may have a temperature signal where we've defined some criteria that calls out that period of time where the temperature is greater than or less than some value that we define. We have an asset that's in operation. Maybe this is a valve, which we'll see in our case here. And we just want to try and figure out, in our case, when our valve is leaking. So we can define when our material is flowing, when our valve is either opened or closed, and then when our condition is essentially leaking in this case, where we'll have material flowing, valve closed, defines that our material is leaking. So one kind of helpful tool that you'll see as you work through the different exercises here is you may not be sure exactly how to solve your problem. So we have an option here called the interactive training. I'll just click on that really quick. And you can just choose the resume button here. In the interactive training, let's see here, we'll go to our skills menu. You saw this just a couple of minutes ago when we were doing those in the intro part. And we're right here on identifying events, but we also have cleanse and quantify. I'm going to choose on the identify events. When I do that, I come back to this image and we can do identifying for either units of time. So we can use a periodic condition to define different types of time. We can look at different values using a value search, which we just did. We can kind of combine stuff together to look at multiple conditions as one. And so we'll refer back to this, this kind of helpful cheat sheet guide as we go through the exercises to help us figure out what tools we want to use. Because these sessions aren't really about the tools that we're using as it is about the analytics that we're trying to solve. But we do need to know how to use the tools to solve the analytics. And so this is kind of that cheat sheet that we have available for ourselves. Make it a little bit easier. So I'm just going to collapse my journal menu again and kind of scroll back down in size here in time. Oops, looks like okay. And so in this exercise, the scenario that we're looking at is engineers are troubleshooting a valve, and we want to identify when the valve is leaking. So what this means is material is flowing while the valve is closed. The reason we want to do this is because we're trying to identify leaks that could be either safety incidents or we could just be wasting material. And if you think holistically about it, like let's say you're a process engineer. If you have a valve that's leaking and you need to shut your entire unit your entire system down to change that valve because it's leaking, one, we want to figure out how much is it leaking and what information can we find about that in an easy to do way. If it's just barely leaking, is it worth shutting your whole process down to change that valve? Maybe it's a non-toxic material. It's not really a problem. Maybe it's better to actually let the valve leak a little bit while we wait for another either higher ticket item to change or another process where the whole system has to be shut down, in which case we can do multiple things at once. And so that really helps us try and figure out using our data to gain efficiencies and optimize our systems and our processes. So to solve this one, we need to bring in a little bit of information first. And while we have our feed rate and we have our limit, let's bring in some information about the valve now. So I'm going to reach out and I'm going to copy feed valve Seeq, copy it, go to my data tab, paste it in, search for it, and then I'll click on it again. And so now I have my feed valve Seeq. And in my feed valve, what I can see is I have two states. It's either open or closed. And it's closed, and then it opens, and then it closes, etc. Let's go back into the journal. So now what we want to do is find when the feed valve is closed. And if you're my live audience, I'd ask you how you wanted to do it. But what we're going to do here is we're going to choose Tools, go to Identify, choose Value Search. I'm going to give this a name called Valve Closed. The signal I'm going to bring in is feed valve Seeq. The operator now. So the program knows that because this is text-based values in time, so a text-based time series on the open and closed states of the valve, we have a little A saying that the information is not numeric, but in fact text. And so it changes what we're looking for. We can either look for when it matches or does not match. So we'll look for when it matches. And then the limit I can type in here is closed. So you may be asking yourself, does it really matter if it's case sensitive? I can see in my data pane that it's capital C. So just for a little bit of proof, we'll use a small case C and we'll call it closed. And I can execute this step. And now I have another condition that's been created that shows me when my valve is actually closed. And so all we did is we were able to read through the signal and say, mark out periods of time for me when the valve is closed. Okay. An important thing to note here is that there's this little blip of data, so it's a little hard to see. So I just want to zoom in on it. So I'm going to click, highlight over that period of time. I'm going to go up and I'm going to choose zoom. So I'll choose zoom. And now I can see that I have a little condition, or a capsule here rather, where the valve has closed for just a few minutes. And I want to try and ignore actually that period of time. And so you may be asking yourself, whoa, do I really want to ignore data? Well, you are the truth of that. You know what data is important, what data is not important. In this scenario, we can see that our valve had been opened, our material started to flow through the system, and for some reason, someone bumped the lever, let's say, and closed the valve for just a split second. And so in this case, this piece of information is not as useful as, let's say, this valve closed event. And it could actually, in fact, skew our data a little bit. So what we're going to do is we're actually just going to ignore this little short capsule here. To do that, when I look at my journal here, it says ignore blips when the valve closes for less than 10 minutes. I'm going to go down. I have the word valve closed. Over to the far left of my details pane, I have a little kind of a box with a pencil in it. I'll click on that. And now I want to navigate down to not ignore short gaps, but ignore short capsules / gaps. So I want to ignore capsules shorter than 10 minutes. And so to note, the lower option here is ignore short capsules or gaps. The upper one is ignore signal gaps. So if I had a break in my data and I wanted to just ignore that and kind of patch the data together, I could choose ignore signal gaps and it would just interpolate over that period of time. But here we're going to ignore gaps or capsules shorter than 10 minutes. I can choose execute. And when I do, I notice that that gap has now, or that little capsule has disappeared. And I now want to go back and just reset this to 1 day worth of data. So I can click in the little box at the bottom and just say 1 day. So now I have 1 day's worth of data. I'm going to go back into my journal menu, and I want to start adding some context. So the different steps that I had done, and I had missed it up on the top one. So let's go up and do that. I'm going to choose the word edit. So that allows me to edit my journal entry. And then I'll scroll down to the first option here. So we used a value search. And then just in my style, I usually try and highlight the word of the tool that I'm using. Go to the little 3 dots. I want to bold it and underline it so I know as I work through again in the future, like what tools did I use? How did I do my analysis? And if you were working in a blank journal, it would allow you to actually write in things like, I used a value search to figure out when the material is flowing. I defined the criteria as my feed rate was greater than my feed rate limit. Stuff along those lines, so that the next person who comes in and looks at your work can actually see exactly the thought process you had and exactly how you did the different steps. So we also used value search again here for number 4. So I'm just going to add that in. Kind of highlight it, bold it, we'll underline it. And then we looked for our blip, so we're not worried about that. And so now the next thing that we want to do is actually save this view. And so to save this view here, the program itself, Seeq, is always saving everything that we do in the background. So we don't have to worry about actually clicking save each time to save our analysis. But what we can do is actually bookmark a custom view. So I'll kind of do the step and then I'll show you what that actually means. So I'm going to write in my word work step here. And now I just want to be a little bit descriptive of what I did. So I loaded data signals. And then created conditions to define material is flowing and valve, and when the valve is closed. Okay, so I can highlight over that. And I like to add the word work step here. Again, you don't have to. What we're going to do is actually create a hyperlink that will then bring back this image. So I type in whatever descriptive description I want to use here. Then I'll go up, kind of copy over or highlight over it so that it's selected. And then use this green Q in the upper left corner. So I'll select insert a Seeq link, and then I'll insert the current work step. When I do that, as I had mentioned, I see a hyperlink that shows up. And so to show what this is actually doing, I'm going to go through and I'm just going to delete this piece of information here called the feed valve Seeq. So before I delete it, let's remember that this piece of information was used to create this blue condition here for the valve is closed. So if I remove this by choosing this X next to feed valve Seeq, what I see is that my signal has disappeared from my display pane, but the condition is still present. So what that means is that Seeq didn't actually delete the signal. It didn't forget the signal at all that I used. But what it did is it essentially just took it away from our view. It's still a piece of my calculation. If I choose this custom work step, that'll actually just return us to that previous view that I had defined. So, and then if I want to step forwards to my latest view, so I have step backwards 1 work step forwards 1 work step, or a step to the latest work step that was completed, we'll choose that. And so now what we have here is what we would like to define as like a cleaner view. So we've already used the one signal, we got everything we needed out of it, and now we can just disappear it out of our view. So in solving whether this valve is actually leaking, what we need to do now is try and find these periods of time where our valve is closed, but our material is still flowing. And so to do that, I'm going to go back up to tools. I'll come to identify, and I'm going to come down to composite condition. So I want to use 2 conditions to define a third. And I'm going to just give this a description called valve leaking. The 2 conditions, one is material is flowing, and the other is the valve is closed. And now I have the ability to combine them together. I need to combine them together in some way. So I can either do a union, so where either condition is present. So if I do that, and we should see an example here, it's essentially taking anytime that either of these are present, it's just combining them together and making one solid condition. That's not what we're looking for here. We have an intersection where both conditions must be present. And so if you think about this in the analytics term, in the problem that we're solving, we need the material to be flowing and the valve to be closed to define that the valve is leaking. And so in this scenario, intersection is what we want to use, where both conditions must be present. And I see in the preview that all these little capsules that are showing up are correspondent to these little kind of jaggy periods of time in our feed stream where the feed is greater than the limit, but we haven't actually defined these bigger flow events. So these are our little periods of time where our system is actually leaking. So I can go ahead and choose execute on this step. And so now what I've done is I've gone through and I've actually figured out where my valve is leaking at. And using a couple other tools, which we're going to do in a later exercise here, we'll be able to figure out how much that valve is leaking. And in fact, we're actually going to do it based on an additive that we're using here. So for number 6, I just need to fill this out and say that I used a composite condition. So we'll bold it and we'll underline it. And then we have a couple of other options here. We can look at stuff in the resulting condition in chain view. And so what chain view is going to do, it's best that I select one of these options first. So let's say the valve is leaking. So I'll choose that. And I see that everything else is kind of grayed out from other conditions besides the valve is leaking one. And in chain view, it's going to cut out all the time period between the capsules. So when I choose chain view, I see all the capsules are now kind of sandwiched together, one right after the other. And these are the little leaking periods. And so if I needed to essentially look at the shape of the curve for when the periods were leaking, it would be easier to see using chain view. And what capsule view is going to do is it actually overlays them all. And so in this view, it may be a little bit hard to see what's going on here, but we will see it in a lot more clarity in a future exercise. So with that, let's go back here into calendar view. And just being good about it, I'm going to save one more work step. So work. And we'll call this valve identify when valve is leaking. Oops, somehow we got scrolled down there, no big deal. So identify when the valve is leaking and add my work step to it. My apologies. Okay, so that is the end of the very first exercise. So let's just kind of recap what we were able to do. And this is really identifying these events, these states, just what we want to do our calculations on. And so pretty easily, we're able to bring in our feed rate, define when the material is flowing by saying that when our feed rate is greater than our limit, we'll say that it's flowing, use a condition to essentially denote those periods of time, and then use another condition after bringing in another signal, which is our valve operation signal, just to say when the valve is actually closed, and then kind of comparing those two together, combining those two together to say that when the valve is closed and the material is flowing, we're going to define the system as leaking. And so that's getting us a little bit more optimal in our system now, where we can actually start to quantify and say that this is how frequently our valve is leaking. And in another step, we could easily say this is how much our valve actually leaked. But that's the end of the first exercise here. I hope that this is useful for you and starting to understand how we're going to work with our data. This is a pretty easy first step, just getting us used to how we're going to use Seeq and how to use the software to start solving our problems. The next problem we're going to get into here is ID2, value decreasing. So I'm going to go on the left-hand side, navigate down and just click on it. And so with this one, we're now into the second problem. So we want to identify periods when a value is decreasing. All right, so let's increase this. And actually, I'm going to click edit, just drag that a little bit bigger. Okay, so we want to identify periods when a value is decreasing. So I'm just going to expand my journal and we'll talk about it real briefly. I can grab this little bar here and drag it down to just have a little bit more room. And so in this scenario, there are many ways of defining conditions as shown in the figure below. We use the interactive training, which again, going to our interactive training menu, we can see the different types of conditions we have. And in this exercise, we want to find how changes in trend, such as increasing or decreasing periods or step changes. This technique is widely applied in use cases such as temperature increases during reaction, level decreases when draining a tank. And in this scenario, we're actually going to be looking at draining a tank and trying to denote those periods of time when we're draining the tank. So to do that, we want to find periods when a signal is decreasing. We're going to bring in some more data. Our first data signal here is tank level Seeq. So I'm going to copy it, go up to my data tab, paste it in, and search for it, and then select tank level Seeq. You go back to my journal. What I want to do is look for a different time duration. So roughly 3 days worth of data or 2 to 3 increasing periods of time. So to expand this out, I'm going to choose between these two arrows for 1 day worth of data. I'm going to set it out to 3 days. When I set it to 3 days, I see a couple of increasing and then decreasing periods of time. Let's add some labels really fast. So I add my name to the lane, my unit of measure to the axis, and my condition name to the lane. And so when you look at this, what we're doing is we're filling a tank. And then at some period of time, we drain the tank, and then the tank begins to fill again. And what we want to try and do, and this is a brainstorm for you to think about. So go ahead and pause this video once we ask this question. Take a few moments, think about how you would approach this mathematically, and then try and solve it. So the question we have for you is, what approaches can you take? We are looking for decreasing periods, and we want to try and find a negative change between one value and the next. So mathematically, how would you identify the change in a signal from one point to the next? And would this approach work on the raw data? If not, why? How might you resolve this issue? All right, so let's say, and you can see that the signal is relatively smooth here. It's a little bumpy, but not too bad. But we're going to show you first on how to cleanse the signal. So we're going to choose tools. So we did identify, we're going to skip quantify and move down to cleanse. So I'm going to choose cleanse. And then I'm going to choose signal smoothing. And I'm going to call this tank level smooth. The signal I want to smooth is the tank level Seeq. The algorithm, we're just going to stay with this Seeq Agile algorithm. If you have questions on how it processes, there's a little green Q here. You could select that and it'll bring up another window that'll give you more details about how the signal works or how the function works. And then we have a smoothing window. We have 3 hours. So let's go ahead and just execute it for now and see what happens. Again, I want to set this on one lane and one y-axis. So this is a really common technique when you're looking at working with time series data. In my previous work, I had a lot of temperature sensors that were in stream systems. And depending on how it worked out, you would see the data would be pretty spiky. You can imagine in this scenario where we're filling a tank that you could have waves moving through the tank. Like let's say that we have a pressure sensor on the one side of the tank that's measuring level for us, or measuring level by hydraulic head. And on the other side of the tank is where the input is, where the flow is moving into the tank. And so you have waves and ripples moving across the top of it. So you could have a bit of an oscillation in your signal. In this, we would want to cleanse the signal. So let's say here that our green value is our cleansed signal. And what we're trying to do is actually just smooth out the data a little bit so that we can take and do some mathematical operations on it. when I look at it, I have a smoothing window of 3 hours. And so the smoothing window is essentially averaging the values over a 3-hour period. So if you imagine data point now, an hour and a half ahead of that data point and an hour and a half behind that data point, it's essentially averaging all those values and attributing it to that one single point. And then it moves forwards and does it again and again and again. And so in this scenario, maybe 3 hours is too much for what we're looking for here. And we actually need something less, because when we look at it, what we want to try and do is really find out when the periods of time when the value is just decreasing, when our raw signal is decreasing. If we look at the smooth signal, it's starting to decrease a little bit too far in advance. So if I kind of scroll over and I see the kick point here, looks like it's 7:25 p.m. If I scroll out, it looks like the signal doesn't actually drop off until 8:26. So it's dropping off an hour early. And that's causing artifacts in our information. So if we were to try and figure out for what length of time this was going to decrease, it could be looking like it's decreasing for 3 hours when in fact it's decreasing for a much shorter amount of time. So it's really important to look at your data, figure out, especially when you start to use smoothing algorithms, of what trends are you really trying to keep and what trends are you trying to kind of smooth out and reduce. So what trend we want to keep here is actually this length of time that our data is dropping and the tank is decreasing, but we don't want to lose the focus on that part here. So I'm going to go and I'm going to open up my tool again. So I'll go down to tank level smooth, scroll over to the left for edit. And I'm going to change my smoothing window. So now I'm going to move my smoothing window down to 2 hours. I see that it's getting a little bit closer to mimicking the raw signal. If I move down to just 1 hour, it gets a whole lot closer to mimicking that raw signal. So I'm actually going to set it at 0.5. And so at a half an hour, we can see that we're very close to mimicking the signal that we wanted to have. And so it looks like when the smooth signal looks like it's starting to drop off drastically, the raw signal is as well. So that's really good. So I'm going to choose execute. And then getting back to, let's go ahead and add some information on here. So we use the Seeq, we use the cleanse tool to smooth or filter our data. So I'm just going to bold it, underline it, because that's just kind of my style and how I like to do it. And now that question I had asked you earlier is mathematically, how would you define and try and solve for these massive decreases in signal? So essentially when signal point 1, and let's see here. So I'm going to kind of try and draw this out. And let's say I have a signal right here, and I have another signal right here. Now let's actually do this. We'll have one signal here, one signal there, and oops, we'll undo these real quick. Okay, so let's say I have one signal here, or a sample point rather, one sample point here, and another sample point. And then to make it a little bit clearer, let's go ahead and add a line in between these. So we have our line over our data, and don't mind the fact that I can't draw super well. And what I want to try and do now is solve for the change in slope. And so if you remember, for the change in slope, we used to use something called, say, dy over dx. And if you're thinking about the derivative, that's exactly correct. So what we want to do is try and solve for the derivative here. I'm just going to clear all these drawings off of this. And to do that in Seeq's term, I'm going to go up and I'm going to use tools and come down to formula. And I want to take the derivative of the tank So we're going to take the derivative of the smooth tank level signal. If I don't know how to code a derivative, and I assume most of you don't know how to code a derivative yet using Seeq, I'm just going to use my search box here for the documentation. I'm going to type in derivative, and I want to compute the derivative of a signal. So I'm just going to select that option. And so for a descriptor, what we're doing is you're going to compute the derivative of a signal. So at each time point, the derivative value is the slope between the current sample and the previous sample in the input signal. So we have our current signal and the previous signal, and we're going to try and figure out the slope of those. To bring the derivative in, I have a couple of different options down here. So compute a first order derivative for the signal. I'll select that. Now I have the word signal and I have derivative, and this is fluent notation where we're going to do where the stop means to do this operation on this piece of information here. So that signal that we want to bring in is actually this tank level smooth signal. So I'll hit plus. So I can insert that, and I can see that TSL2 or TSL2 is our tank level smooth. I can also rename this. So if I just click over the name of it, I can call it tank level smooth. And when I rename the signal, I see that in my actual formula, it renames it for me as well. And if I needed a higher order derivative, so I only need the first order derivative since I'm looking at the change in value, the slope. If I needed a higher order derivative, I could pull in this next option here, which is compute. And here it says the second order derivative, but it's derivative n and a 2. If I change that to a 3, that would be the third order or fourth order, depending on whatever you needed. You would have access to that if you needed to. And so I can choose execute. And when I choose execute, now I have the derivative of the signal at every single point in my tank level smooth signal. And so let's get back to the real question here. Actually, let's be good note takers. We'll update this. So we use the formula tool and we use derivative to calculate the slope. So I'll just bold it. Oops, not strike through, but we'll underline. And then we'll use the formula tool. So again, we'll bold it and underline it. And now what we want to do is try and find these periods of time. So go ahead and hit pause for a second. But before you do, think about how would you do this? How would you search for those values when the tank level is decreasing in value? So we've gone through, we've created a derivative now that tells us the slope. And so now we're going to look for when that slope is negative. So how would you find when that slope is negative? So if you've been screaming out saying you're going to use the value search, that's absolutely correct. So we're going to go up here to tools, go back to identify. I'm going to choose a value search. So remember, a value search is defined when a signal is greater than, less than, or equal to another signal or fixed value. So I can select that. And I'm going to call this tank level decreasing. And then select a signal to search. The signal that I want to search now. What signal do you think? We could use the tank level. It's not what we want to use. The tank level smooth, good, but no. We actually want to use the derivative of smooth tank level signal. So I'm going to select that option here. And then the operator is going to be less than, and the limit is going to be 0. So we are trying to find essentially when the derivative is negative. Because a negative derivative, if you remember from calculus class, means that the slope is decreasing. The slope is negative. So we'll choose execute. And now I see that I've pretty quickly been able to define these periods of time when my tank level is decreasing. In this operation, we want to know when it's decreasing, but we actually want to know how long is it decreasing. And there's another question here too. So I'm going to step back a half a step. And so to step back a half a unit in time, I can just click the one arrow to the left. And I see that I have a couple of little capsules here where the tank level looks like it's decreasing for just a split little second. So here, maybe it decreased for a hot minute because someone bumped the controls to during the tank. Here, maybe we just had a bit of a big wavelet into the system and we didn't smooth well enough. So we just want to make this capsule go away because we're really just looking for these larger decreasing periods of time. So I'll go back to tank level decreasing. I'm going to open that up. And then again, I'm going to ignore short capsules And if I'm not sure how short of a capsule I want to ignore in this analysis to just capture these bigger decreasing periods of time, like let's say I want to find out how long this capsule is. In the lower left is a really nice way to do it. So this is our capsules pane, which we haven't seen show up too much before. I'm going to go over, I'm going to choose the first option here, which is add a column. And I want to add the duration. But you could see that I can, right now I'm selected, I want to see the start time of the capsule. I can choose the start and end time, or I can choose the duration. So I'm going to choose the duration because that's going to be pretty important information for me. And so now as I look, I have the start time for the capsule. This is the first one on August 20th. I have one on August 21st, and the different durations of them. So if I select over here to the left and I click on that little box, it's maybe a little bit hard to see, but you can see these ones are essentially lighter in color. They've been grayed out a little bit, and this one's still selected. So it's good to know that that one there is for 5 minutes long. And then I have another one right here. So let's go ahead and select that one. And I see that that one's for 26 minutes. And so if I'm working through my analysis and I really just want to find these larger decreasing periods of time, because that's all we're interested in, what I can do is I can ignore capsules shorter than 30 minutes. So I'll go ahead and I'll edit this and say, ignore short capsules, capsules shorter than 30 minutes, and choose execute. And now I have a cleaned up view where really this piece of information has disappeared and that little other piece of that other small capsule has disappeared. So really I'm just calling out my larger decreasing periods of time. And if someone was interested, the first one here, we're draining the tank for about 54 minutes and then 56 minutes and 53 and then 49. So all in all, somewhere around 49 to maybe 56, 57 minutes is about the duration that we're draining the tank. And so that gives us more information about our process. Maybe that's telling us if we knew the rate at which material was coming into our tank and we knew how long our tank was draining for and how much it's drained, we can start to get more information about quantifying our process, figuring out one, is the tank draining for the right amount of time, and different rates at which it's draining to. And so I'm going to go back into the journal and I'm just going to add some information here. So use the blank tool to find when the change. And so the tool that we used here again, you may be asking yourself, is value search. So I'll go ahead and highlight that, bold it, underline it. And then I'm going to go through and add my work step. And this is find when the tank is draining. Go ahead and highlight it. I'm going to add my Seeq link. And you may be noticing now that I did not add a Seeq link earlier through the analysis. Well, if I wanted to go back and I wanted to clean up this view and add those steps back to it, I can scroll up and I can essentially delete the other signals out of here and just resave custom work steps for it. So again, they're not deleting the signal from it. It's actually just removing it from view. So, or I could do another option, which is called dimming. So in the first part where I wanted to load data, let's say we'll go here. So we're going to load data and smooth the signal. So I can choose the tank level Seeq and then tank level smooth. And then in the top option, I'll choose dimming. And that essentially hides all the other signals from view. So I can go in and type in work step. And so I'm going to call this work step load data and smooth smooth tank level signal. I'll highlight it and then I'm going to insert my Seeq link for it. And now for the next one here, where I wanted to solve for the derivative, let's go ahead and add in the derivative. And I can call this another work step. And I'm going to call it calculate derivative of tank level smooth. smooth tank level. I'll go ahead and add another Seeq link to that one. And then the final step, and maybe really the only important thing for us to note is just the tank level and when it's decreasing. So I'm going to unselect the tank level smooth and unselect the derivative of the smooth tank, but I'm going to add in now the tank level decreasing. And so I can solve for another work step and show, we'll call it show only tank level decreasing. So that's just kind of a nice little helpful way that if you've accidentally forgot to create work steps, but you really want to be able to share your analysis later and go back through and add the work steps in so that someone else can follow along with you, this is kind of how I would go about doing it. But as I've been mentioning, it's really important to share your analysis and to add some insight to it. And so I might add another note in here in my journal. It says, note, the tank level decreases for about, or the tank, let's say the tank drains for, now I'll just do an approximately 49 to 56 minutes per event. So maybe I'm passing this over to an operator who's trying to figure out, is my automated control system that's telling us how often to drain the tank, is it running correctly? And so now they can see without having to go back through and recreate this analysis or even look down at my capsules, they can see roughly how long this tank is draining for. So that's kind of getting more to the source of what we're really trying to do here. It's not so much about how to use the program, it's really about the insights that we're able to gain. And so now someone else doesn't have to go through and create this in the future. Even better, I can scroll kind of through in time. I can scroll backwards in time a good bit. So let's say, and I can also look at this, maybe I needed 1 month worth of data. So over a month worth of data, we can see all these periods of time at which our tank is draining. So with that, that kind of concludes the next exercise here. And we're going to get on to our last exercise, which is looking at quantifying. And so you can come back here into the skills menu. So we've been spending a little bit of time identifying events, and now you're starting to see kind of how we go through identifying events and what the utility is of it. We've touched on a little bit of cleansing. So we've used one of the pre-built tools here to cleanse our signal. And so you can see if our signal was pretty spiky and jagged, we'd be able to smooth out our signal so that we can look for our derivative and get a better result there. And now we're going to step down into this last stage here for quantifying. So actually back in the skills menu, we can look at quantifying. And so we can use some equations, and we can use kind of our pre-built tools to do calculate statistics and do some aggregations around our data. So I'll choose quantify. And just looking at the cheat sheet here, we have essentially a data signal, it's going on, and we have some unit period of time, and we're trying to figure out something about our data, our signal, and what's going on maybe on a daily condition. So maybe every day we want to figure out the average of how much of some product that we've used, which is actually what the next exercise is going to be. So to get started on that exercise, let's navigate down to Q1, product produced and value. So I'll go ahead and click on that. And then I'm going to expand my journal menu again, edit it. And when you're working in journal, if you add a box and it's not the right, you want to like increase the size of it, go ahead and click on it, and then you can just scroll it over a little bit. And so that would just be adding a cell from this insert table. So in quantify, we want to do a calculation, and there's a number of ways to calculate metrics, equations, statistics, or value distributions. The most common calculations include signal statistics within capsules, or conditions rather. And we want to find the average, such as finding the average of a signal within each capsule. condition statistics such as the duration of each event capsule, and custom equations and formula like the equation bar in a spreadsheet, except where this is a lot more flexible and much more powerful. So we just briefly touched on kind of the cheat sheet that we had, but when we look at quantifying, we can look at signal statistics, and we can do stuff like creating histograms, which we'll do later. And so we'll get into this a little bit more as we go through. But the first thing we want to do is the scenario for exercise here is we want to find the total amount of additive used during each day and the cost of total additive used. So in this image, I'm just going to scroll it up and make it a little bit bigger for us. If we have an amount of additive in our system, and we just want to find each day, so let's say that these are a daily condition, just the total amount per day. So I'm going to bring in my first signal, which is the feed rate Seeq. So I'm just going to copy that. It's the same signal we used in our very first exercise. I'm going to go back up to my data tab. I'm going to paste it in and search for it and bring in my feed rate. Let's go ahead and add some labels again. So I'm going to add my, click on labels, add my name to the lane, add my unit of measure to the axis, and then I'll add my condition name to the lane again. And now we're going to do something slightly different. So we want to see 7 days worth of data. All right, so let's change this to 7 days. And then it loads up. And the first thing that we want to do is we actually want to make a condition with a capsule spanning each day. So remember, in the exercise we're doing, we want to find the total amount of additive used during each day and the cost of total additive used. So the amount of additive used each day, I need to create a, I'm not sure, I'm going to come back to my interactive training. I'm going to go back up to identify. And now I want to identify kind of a unit of time. And that unit of time here is a day. And so we're going to use a periodic condition to define repeating periods, such as days, weeks, and shifts. So I'll come in here and I'm going to go to tools. I'm going to choose identify. I'm going to come down to a periodic condition. I'm going to call this daily. The duration, I can do hourly, I can do hours, I can choose daily. So I'm going to choose daily here. But note, you can break it apart by year, quarterly, whatever you're really looking for. Even looking at work weeks versus weekends. So choose daily. And then maybe I had something that was occurring every day of the week. So which is what we have here. We're just trying to figure out the total amount of additive used each day. Or maybe I just wanted to look at how much did I use on Sundays or Mondays or whatever days of the week I wanted to. The next part is that we actually can define time zones. So this is just a really important thing to think about. When you're doing your analysis, you're solving for amounts, like in our case, the amount of additive used in a day. And I'm based over in Colorado, but maybe I'm working with a colleague in Kuala Lumpur. I want to make sure that the values that they see are going to be the same values that I see. So if I am creating this for a process that they're running, maybe I'm the data scientist or the engineer working here in Colorado, but the process is actually occurring in Kuala Lumpur. I can go ahead and set and choose a time zone that makes sense for them so that we're replicating the analysis for their time zone. But for the instance here, I'm just going to stay in Mountain Time Zone and I'm going to choose execute. So we'll execute this step. And I now see that I have my daily condition created here. And note that it says daily 2. I'm not sure where that 2 came from. So let's go ahead and clean that up. So I'll just choose edit, take this 2 off, and we'll execute this again. Okay. So another important thing to think about is this is not hooked up to any processes. So we can go through and we can kind of test things out and change parameters as we need to really make sure we're getting the analysis that we intend for. So it's just another important thing as an engineer. You want to not just run calculations, but run calculations and make sure they make sense. In our case, we are just editing a name, but it's just a nice feature to have here. And choose journal. And as a good note taker, we used periodic condition to make a condition with a capsule spanning each day. And then the next part is we want to use some tool to find the total amount of additive used during each day. So if I'm not sure what I want to do, I'll go under tools and come under quantify because I need to quantify something now. And I have two different options that make sense here. I can either use the signal from condition, which is summarized data during a capsule, like a min, max, average of a signal or count duration of a condition. Or I could choose the scorecard metric. And this is essentially doing the same thing that a signal from condition would do. It's just producing it in a table, but allowing us to have color-coded thresholds. So we're going to choose signal from condition first. And if I remember correctly, this is the total amount of additive used during each day. So we'll call this total each day. And so it's the total additive used each day, or we can be more specific, total amount of additive used each day. The signal that I want to bring in now is the feed rate Seeq. So we're just going to bring in our data signal. The statistic that we want to use. So you might be asking yourself, how would I solve for the amount of feed rate used or the amount of additive used every single day? We are not looking for an average, so we're not looking for a time-weighted mean or a count. And if I scroll down, I have two options that kind of come to mind. The first one could be a sum. So I could sum the sample values. But really what I'm looking for is to take the definite integral of this feed rate signal. And so if you think about it, we're going to integrate over time. That time period is a day. We want to integrate the values of the feed rate over the course of the day. So I'm going to choose totalize. The bounding condition here is going to be daily. In this scenario, I do not need to worry about convert time units because the time units are going to come out through the integral itself. And then lower down here, I can choose where to put this, where to essentially put the summary timestamp. And I get a preview that pops up. And so what I see now here is I have in units of kilograms, the total amount of feed used every single day. So if I click, I have 1 day worth of data showing, or 1 day marked out here in my condition. And I have exactly one value, which is kind of the integral of this entire feed rate signal through the whole entire day, just summarized into one value. All right, you might be asking, why couldn't I use sum? Well, let's see what happens if I do use sum. So I'll click on totalized. I'm actually just going to choose sum instead. When I choose sum, I see that my units are actually in kilograms per hour, and they're drastically different. So I'm up here in the order of 2,200 kilograms per hour versus if I'm in totalized, I think I'm somewhere around 2 kilograms, or I'm sorry, around 70 kilograms average per day. So what is the difference? When I choose sum, it's actually taking every single sample point and just adding that to the value. So it adds sample point 1 with sample point 2 with sample point 3 over the course of an entire day. But it never actually integrates it over a period of time. And so we're really looking for that area under the curve here for all of these. Let's go back to totalized. And I can execute this step. And now one thing I like to do here that I think is really, really critically important. If I look at this and I just take a 2-second glance at it, it looks like on the 19th, we've used significantly more additive than we used on the 18th, or the 21st, or the 23rd, or the 24th. But in reality, we're using about the same amount. And so it's just an effective Y scale here right now. So to adjust the Y scale, I'm going to go down in my details pane. I'm going to choose customize. And then I'm going to scroll over. And so I have my total amount of additive used each day. If I scroll over, I'm going to unselect the auto scaling, and I'm just going to set this from 0 to 80. When I do that, it really helps show that almost every single day we're using relatively the same amount. It varies a little bit depending on the day, but not as drastically as it had shown before. So just something to think about whenever you're producing your results. You want to make sure that there's no kind of hidden, maybe not even hidden, but visual changes that would make someone think there's bigger changes in your data than you actually have. So just a uh, kind of a note to do here in that nature. Go back in the journal. So we used totalize, or signal from condition, to find the total amount of additive used each day. And now what we want to do that we know how much material we're using each day, we want to figure out what does that cost to us? And so if you want to figure out the cost, and we have this in terms of kilograms, and we have a value here, we know that it's $682.53 or dollars per kilogram. We're going to go and we're going to choose, I'm just going to copy this in, go up to tools, come down to formula, and I'm going to give this a name of cost of additive per day. So what I want to bring in then is the total amount of additive used during each day. It's in units of kilograms. And then I want to multiply it by the dollars, by the cost of the material per kilogram. And I can choose execute. And so I see I have these little dots. Let's go ahead. If you've already unclicked customize, go ahead and click customize again. And for the cost of additive per day, we're going to change this to a bar graph. And now we have the total cost of additive used each day. And again, just trying to adjust the y-axis so we don't have kind of these issues of scale here. I'll change that from 0 to 60,000. And I also want to add some clarity here and put in my comma separators for the thousands places. So I'm going to go back over where it says cost of additive per day. To the left is a little I for item properties. I'll go ahead and click on that. And then when I scroll down, this option here gives us some details about the signal that we have. We can add a description for it. We have the formula that we used to create the signal. And we want to go down here to number format. I'm going to override it. I'm going to choose number. And I actually don't need the 2 decimal places at the end, so I'm just going to remove those. I have my comma here for the comma separator. I can choose apply. And now I have dollars. And in fact, if I wanted to, I could just click in front of this and add in a dollar sign and then apply it again. And so now I have dollars. Yep, I have my additive used in terms of dollars per day. And then I can click close. And then go back into my journal again. So for number 3 here, we used formula to calculate the total cost of additive used per day. All right, I'm going to add a work step here. And in fact, before I add a work step, because the cost of additive used is actually something in terms of money, I like to turn it green. I live in the US, and I always think of money in terms of green, and we're always going to get as much green as we can. Over on the far right, I'm just going to unchoose customize so that the word lane disappears off the end of each of these signals. And I want to share this analysis with someone else. So remember, as we talked about it earlier, you can do the coolest analysis in the world, but if you can't share it and you can't help someone else gain the insights from the work that you've done, you really haven't done a good job as an engineer, because the important thing is to do the work, add context to it, and share it with another colleague. So to do that, we are going to, let me add a work step and then we'll go ahead and share it. So come down here, work step, cost of, call this the cost of additive used per day. And I think by now you're probably getting really familiar with how to do the different work steps. And so really all that's important for me to share with my colleagues, so when I think about it, they don't care about the daily condition. They do not care about the feed rate that I'm using. I don't think so, at least. The kilograms, probably not as important for them, but really what they're interested in here is how much are we spending on this process every single day. So I'm going to go ahead and choose the check mark here next to cost of additive per day. I'm going to go up and choose dimming. And now I can see that I have just the cost of additive per day. And so to share this, we're going to go into another program called Organizer. And so I'm going to go back to my main folder here. If you don't have this folder available anymore, because when you clicked on the green file, it just opened up directly for you, just go ahead and copy this URL. So I'll go ahead and copy it and add another worksheet in here. And then I can now go and just choose this, actually just click on your name, and that should take you right back to the main folder. And now I'm going to open up the organizer template, which is the blue one. So organizer, it's mostly laid out the same way that Workbench is laid out here. We have our different worksheets on the left-hand side. We have a little plus to show our worksheets. Again, we can collapse down the worksheet so we don't see them anymore by clicking this little gray bar. We can collapse the properties in the comments tab as well by clicking this bar. We have some formatting tools across the top, and we have where our information is going to show up when we add context to it. So to get started here, we'll come down to the single unit report. I can add my site name. So let's say my site name here is CFE. CFE course, my unit name. You can call the unit name anything you wanted to. It's a report. You can add your company's logo here if you wanted to. And then we're going to come down into the first step. I'm going to come in front of step one, put one single or two spaces here. And now what I want to do is actually link back to the other document. So to do that, I'm going to go and come back to my workbench analysis. I can either copy the URL directly, or I can go up and choose Get Link. I'm going to choose Get Link. And I have a couple of different types of links available. I'm going to first pick the edit link. And what the edit link does is it allows someone else to have who gets the work or the organizer template either read or write access. I can give a view only link, in which case it would only give them the ability to view the analysis, but not actually make any changes to it, although they still do have significant ability to kind of move through the document that you create. And a presentation link really ends up creating it more as a kind of a dashboard that you would share, or when you're doing a presentation, you'd get a view that would work really well for that. And on your own, you can go ahead and explore through what these look like. So we're going to choose the edit link. I'm going to choose the two sheets of paper to the right. So copy the URL to the clipboard. And I get a little link that says it's copied to the clipboard. Go back to my single unit report. And now what I'm going to do here is I'm actually going to go, I have my cursor blinking exactly where I want my information to show up at. And I can choose this green Q. And now I'm going to insert a link. And then I can paste it in. So in the program here, if the link is valid, it turns green saying, yep, you've got a good link. If it turns red, it means you're missing some piece of information and it's not a good link. So let's just keep it as a good link here. And I'll choose use. And then I have several different options as well. So I can change the content size, the shape, the font size. I can change around the date ranges, and I can insert it. So we're just going to insert it here. And this is what we would call our previous week, or really, we'll get to defining what the previous week is here in a minute. But first, we're going to add in the one more image of this. So I'm going to copy it, come into the current week. So go ahead and put a space in right in front of step 3. Actually, we'll do 2 spaces. Oops, it's not where that was supposed to show up. It's right here. So to do that, all I did was click on the previous version, Control C, move to where I wanted it to be, and chose Control V. Now, all I did was bring in the information from the workbench analysis. And when it brings it in exactly with the dates and all the settings that we had over in the other application. What I want to do, though, is I want to define the previous week and I want to define the current week. So I'm going to change my date range and choose this plus sign here. First, I'm going to define the previous week. It's a week, so we're going to call this 7 days. And we can see that we have it right now set up at 10:24, which is currently today. I'm going to step back a whole time period. So 10:10 to 10:16, 10:17. And I can choose save. And then I want to create one more date range. And I'm going to call this the current week. And call this one 7 days. And then step to the current time, and I can choose save. To apply it to these images, I'm just going to select the image, choose update Seeq content, and then I'm going to select the date range that I want to apply, and that's the previous week. And I can insert that. And then for the next image, I want to insert the current week. So just in the same way, I'm going to choose the Q, and I'm going to choose current week. Then I can insert this. So that's how we would put together an organizer template that has the previous week and the current week applied. And so if you think about it, we were pretty easily able to load the data, create a periodic condition to figure out what each day was. And then we were able to totalize our signal over the course of each day and take the definite integral and find out how much additive was used each day. And then apply a value to it for how much additive was used and what the cost of that was. And then to be able to share it with our colleagues, we're able to bring it over here in an organizer, add the 2 images in, and then just apply the date ranges to it. And so as we work through time, I can have this set up as an auto updating date range so that each week I can schedule it and it'll just go through and it'll update these graphs based on the changing times. So 1 week from now, this one here will show the current week, which will show up, let's say it's next Sunday night, which will be the 31st of October. And this one will show this image here, which will finish around the 24th of October. And I can have it pre-scheduled so that every Monday morning, it just automatically recalculates for me and makes those changes in value. And so with that, that is all we're going to cover here on Organizer for now. We're going to come back into Organizer in one of the future exercises. And there I'll show you how to schedule those auto updating time ranges. And with that, that is the end of all the materials we're presenting here for session 1. So just to do a little bit of a quick recap now, let's go back into our skills menu. So in solving your analytics problems, first thing you want to do is look for identifying the different periods of time that you want to do your calculations over. You may need to cleanse the data so that you can smooth it out a little bit, so you can reduce the spiky nature of some time series signals, so you can really get down to the essence of the trend that you're looking for in your signal and not get skewed based on all these potentially erroneous pieces of information in there. And then we can solve some, we can use quantify to actually calculate some metrics about our data. In the exercises that we did here, we looked at identifying through what we called conditions, where we were able to bring in our feed rate and define a limit and just create that criteria that said that anytime our feed rate was greater than our limit, We're going to mark out that period of time. We were able to use another condition to find when the valve was closed. And then we were able to combine those two to talk about when the valve was leaking. And so if we were able to combine this step here with the previous step, so let's say our goal wasn't to just find when the valve was leaking, but was actually to find how much. Now that we've gone through and we've shown you how to do quantify, think about how you would actually combine this Q1, this product produced in value, with ID1. So if we wanted to figure out how much product was actually leaking and not just the fact that it was leaking, I could go into tools, come down to quantify, choose another signal from condition, and let's call this amount of leaked material. The signal that I want to choose now is the feed rate Seeq. The summary statistic that I want to look at now, if you remember before, we used totalize, and that's exactly what we're going to use again. We want to take the definite integral of all these little periods of time where the valve is actually leaking. The bounding condition, again, because we're doing this, it's a feed rate kilograms per hour, but we're integrating in time. The time units will cancel out and we'll be left with kilograms. And so our bounding condition here then is the valve leaking. So I can figure out the feed rate based on either when the material is flowing, which is all these periods of time, when the valve is closed, or when the valve is leaking. So I'm going to choose valve is leaking, and I'm going to choose middle again for where I want my signal, and then I can execute this. And so now I'm able to go through and I can solve for the amount of leakage per every single event. But maybe I wanted to find the amount of leakage per day, because that's what's really important, is how much product am I leaking every single day? Well, if we think about how we did Q1, I can come back into identify, choose a periodic condition now, and call this daily. And then execute that. So I have my daily condition again. And I can go into quantify, do another signal from condition. We'll call this of product leaked per day. So now I have my amount of leaked material, and I want to find this time, I actually want to find the sum. And the reason I want to find the sum is because I've already gone through, I've used my definite integral, and I've calculated out the area under the curve for each of these, and I've given one single value, which is the amount of product leaked per event. So I've already integrated through time, and I have now a kilogram value per every single event that's leaking. And so now I just want to sum those up over the course of every single day. So my bounding condition now is going to be daily. I'll put my timestamp in the middle again, and I'm going to choose execute. And so I have one single value that shows up, but actually I'm going to change this out to looking at a larger period of time. Let's call it 3 days. And so now what I'm getting here is a value of where my system is leaking every single day. I'm going to choose customize again, because I always like to see this not kind of auto scaled like Seeq likes to do, but scaled appropriately. So I'm going to call this 3. And now I can see every single day I'm leaking. On the first day, I have, it's like somewhere around 2 kilograms, and another around 2 kilograms on the next day, and the same for the last day. Okay, so that kind of ties it all together for both getting used to just using Workbench itself. This course isn't about how to use the tool as much as it is how to use analytics to solve your problems. And some of the conditions or the thoughts that you have around each each operation that we're looking at. And so we've been able to go through now and look at identifying events, cleansing, and quantifying. And we've been able to pretty quickly and easily quantify several different systems so that we can learn more how to gain insight from our processes, as well as how to optimize. In much in that same way we did the last exercise, we could now take this kilograms and multiply it by a dollar value of the product to figure out how much money are we losing every single day by letting our system leak versus maybe we know how much it costs to change out that valve and potentially the material is non-toxic, so we're not worried about the fact that we're leaking a little bit of it. If this is a toxic material, obviously we change it immediately and we don't worry about the dollar values because the dollars are much less important than the safety in the environment. So with that, I just want to thank you for sitting through session 1, and I look forward to seeing you in session 2 and session 3. In session 2, we're going to be looking at monitoring. So we're going to go and we'll be looking at monitoring of our data. And to monitor it, we'll be looking at tree maps, and we'll be monitoring multiple assets. We'll be using tables to monitor our data so that we can calculate different statistics and aggregate them either during the condition or through time. And then in session 3, we'll be looking more at model and prediction. So we'll be doing regression models. We'll be doing some forecasting on our signals itself. And then we'll also be using formula a good bit here to essentially do a lot of cleansing of our data. We'll be looking at removing outliers, or look at kind of gap filling of our data as well. And with that, I look forward to seeing you in the future sessions. Thank you very much.